Okay. Hi, I'm Sureena, and I'm an incoming senior at Monte Vista High School. My main project is the sound reactive equalizer skirt, and so I am my demonstration. So if you can tell, you can clap and it'll make a sound, or like if I don't talk at all, it won't do anything, so that's pretty cool. Okay, so once I was finished with my main build, I really wanted to add a really cool modification, and I've always been interested in fiber optics, and so, modification. So what I did is I put optical fibers on LEDs, and I wanted them to mimic sleeves. They're not all the way there, but I still have 2 more days. So it's 3 more days. I have 3 more days. This experience was definitely very eye-opening, and I learned a lot. So for instance, the LEDs that I'm wearing right now are very intelligent. They're so intelligent that they can actually be addressed individually, so they can be programmed individually while still being soldered onto all the same data wires. And also, they have an internal oscillator and a 12 voltage programmable constant current control, which basically, what that means is that it just, if the current goes too high, the LEDs will stop receiving current just so nothing bad happens. So I also used fiber optics, and the way that they work is that you have to shine a light through the core of the fiber optics. So I use LEDs, and the LEDs will make a total internal reflection inside the core, so you can only see from the very edge and nothing on the sides. So I experienced a lot of difficulties and a lot of just overcoming obstacles, and like right now. So one of the first obstacles that I had to overcome was when I finished soldering all my LEDs onto my skirt, the last 8 wouldn't light up. And so I tried everything. I tried debugging the code, I tried checking the voltages on all the LEDs that were not lighting up, and then I even tried desoldering the last LED to check if it worked on its own. And those all worked. So what ended up being the problem was that my first LED that wasn't working was broken, so it was restricting current from flowing to all the rest of them, like a Christmas tree lights. So I had to end up taking that out of my design, and it did mess up the design, but that's the compromise I had to make. And then the second problem I ran into is that I thought I needed another battery for my arm sleeves, and so I bought a lithium-ion battery. But then once I got it, the challenge was, how do I connect my 2 arm sleeves to 1 battery, but then also connect the 2 arm sleeves to my microcontroller, which has a different power source. So it was pretty challenging, but I had worked everything out on the breadboard and was ready to put it on my PCB when I realized that I didn't even need the extra battery because my current power source provides all the power that I need. So that taught me the importance of checking all your materials before you go out and buy stuff. And then lastly, I do have a lot of wires all over my project, so it got kind of tedious to identify which is which. But one way I made this easier for myself was I took electric tape and I labeled every single wire, either data in, data out, power, or ground. So to say I learned a lot over BlueStamp would be a complete understatement. I learned how to find the charge of an electrolytic capacitor, the pins of an LED, the challenges of soldering, the pain of desoldering, the compromises that you have to make in engineering, and the power of a great friendship. But overall, out of all of it, the greatest thing I learned was confidence. Whether it be solving a problem on your own, or asking for help when you're really stuck, I can undoubtedly say that the greatest thing I learned was self-confidence. Thank you. Okay, do you guys have questions? Or just more clapping? Oh, yeah.
How was the last 1 hour?
Oh, yeah. So when we had intermission, I was like putting on my entire outfit just to be ready, and then I turned my power bank on, and usually you get that happy feeling when all the lights turn on, but it didn't, and so I kind of had a little breakdown, but it was okay because I just turned the microcontroller on and off again, and then it worked. Yeah. Any other questions? Oh, yeah.
How come you don't see light anywhere besides the end of the fiber optics?
Yeah, so I went into a little overview of fiber optics, but what fiber optics are is basically it has a core, and then it has cladding to protect the core, and then it has strengthening Kevlar fibers. So what happens is when you shine light through it or shine some input through it, it makes a total internal reflection. So what it does is that it just bounces off the wall and then bounces off the next wall, and then on and on and on, until the very end, and when there's no more place to bounce off, it just shines. So that's why you don't see it on any of the ends. Yeah.
Also, this great friendship.
So, like, I came to my first day of BlueStamp. I was a PM section student, and I was like rushing here because I had just come from like a meeting that I had. So I was like rushing, and I came out, and I was like out of breath, and I like walked. I was right there. I was outside, and then like one of my closest friends in the entire world, Vijaya, she came up to me and she walked in. She was like, "Hey," and I was like, "I don't know you." No, I was like, and from that moment, I knew that like we would just get along instantly because like I'm the exact same way. So, yeah.
Well, people speak next to you, and your LED still blinking. Or
Yeah.
Oh.
Yeah. Yeah.
How does that work
How does what work?
in terms of like the voice like
Oh
activates?
yeah, so I have a microphone in my skirt, and so the microphone gets taken as input into the code, and it gets transferred to decibel levels. And based on if it's a lower decibel levels, it'll usually show like green light at the very like ends. But then as it becomes higher decibel levels, it'll show like darker light, and it'll show more LEDs. Yes. Yeah.
Do you want to try the lightsaber? Maybe we can cut.
Yeah.